this video be covering one of my pet peeves. This kind of a rant video. Get the safety video out of the way, then get my rant video out of the way. One of my pet peeves that I always see on electronics, pretty much from any manufacturer, I've seen it from all types of equipment manufacturers and everything, is semiconductors like the TO220 transistor or TO220 style regulator, voltage regulator, put on a circuit with inadequate or no heat sink at all, just using the case for heat dissipation. I know the specs on some linear 780XX to 79XX regulators, 79 and 78 series regulators specify up to 1 watt dissipation without a heat sink, but that is generally assumed in open air with no clutter around it or anything else like that to impede air circulation. But when you pack it in a densely packed circuit with other heat generating devices around it, then the amount that this little voltage regulator, in this case a 7812, the amount it can actually dissipate without a heat sink is far less than 1 watt. That's something that it seems that most manufacturers do not exactly comprehend, because as I said, I've seen it all in all brands and types. Like, for example, a radio manufacturer which shall remain nameless, not because of anything related to them, but just not to show shine undue light onto them, because as I said, I've seen it in all brands and types. CB radio, and if you look at the construction of the radio in question, you will see, if it focus here, I'll have to stop the camera and refocus. Alright, let's see here. If you see on the circuit design, they have a 7809, a 7808 here, which supplies all the PLL circuits on the CB, and it's within about 1/4 inch of the outside case, but there's no heat sink flange to the case or anything like that, so it just left out free bird to dissipate whatever heat it can in a small little enclosed case like this, packed around with all the other little heat generating components. And the other heat generating component that happens to be right beside is the audio output amplifier with its own little heat sink right there, which again is not connected to the case. So when you have this one running under idle, generating heat all the time, and then when you get this one with the volume turned up, those two get pretty dang warm together. And in this particular model of CB, as I said, which shall remain nameless, had 3 of them given to me before with the same problem, intermittent operation and no operation at all. And on all 3 of them, it was the same problem. This 7808 regulator unsoldered itself from the circuit board, considering that solder melts at 300 some degrees Fahrenheit. That gives you an idea of how hot this little group of circuits was getting. And again, they're within a 1/4 inch to 1/2 inch of the case, but no attempt by the manufacturer to put any heat sink flange to the case or anything to dissipate the heat. it's forced to dissipate it via the open air in the circuit and then dissipate it out through the case and stuff a slow way, allowing it to get a lot hotter than it would if they had properly heat sinked the two components. And as I said, I've seen that in device, radios, CBs, electronics of all types, almost without exception. I've not seen it as much in newer equipment and stuff, because it seems the thermal design and life cycle management design programs and stuff they're using is pointing out that obvious fact to them. So extremely hot components that have a tendency to unsolder themselves, I've seen less and less, but still see them on new equipment here and there, especially when you take apart an old radio and you see a circuit board blackened around that particular device, whether it be, it's usually like a shunt regulator or a series regulator, either a series pass transistor or a 78 series or 79 series voltage regulator, but usually it's one of the above, or the TO220 mounted transistors and stuff that generally have the same general fallout, because the person that was designing it thought, well, the specifications say 1 watt, and according to this I'm going to be generating 0.95 watts, so I can forego the heat sink and everything. Yet they have it packed in a little case with no airflow and everything, and then when the product starts coming back under warranty or whatever failure, with the regulators literally falling out of the circuit board, then I wonder why. And in this situation, I'll give you an example of how hot that one little component is getting. To do the demonstration, I have a meter, a temperature probe, and a little ball type thermocouple. Well, you can't really see it too good there. That I'll mount to the flange of the TO220 transistor. No, not transistor, regulator. Mount it to it, power it up under voltage within its normal rated specifications, and let you see how hot it gets after a certain period of time here and stuff. So I'll rig that up and I'll come back to you here in a second. There we go. Got the thermocouple mounted to the TO220 voltage regulator. Got it clipped so I can put the cover on, flip it over, hook it up to the temperature meter, power it up, and check how hot the thing will get. Now keep in mind that this is in a nice, relatively mild 74, 75 degree room, which when you actually have the thing out in the vehicle in a nice 80, 90, 100 degree day, the actual temperature will reach, because of the heat baking effect, will be a lot higher than what we'll see here. But I still say we'll see a pretty warm temperature when I get everything cranked up here. I'll get to that in a minute. Alright, got the temperature probe hooked up to the radio, to the power supply. As you see, saying about 24, 25 C, which corresponds to about 76, 77 degrees in the room. And now, camera, I can get a picture of it here. It's turned straight. We'll turn power on and turn CB on. and watch the temperature start going up and up and up. In a few minutes I'll come back, about 5-10 minutes here, and see how hot this sucker really gets here. Alrighty. It's not been 10 minutes. I've sat there idling, and the display says 100 Celsius, which is about 212 Fahrenheit, or exactly 212 Fahrenheit. And that is with no antenna hooked up, no mic hooked up, so there's no audio output, so the audio amplifier is not generating one bit of heat. Just the regulator by itself cooking along at the temperature of boiling water inside that little case. And you look at it from the outside, nothing even warm. But because of the poor heat sinking on the regulator on the inside, it just literally cooking on the inside. Yet the dude that designed this radio thought it'd be a good idea to not use a heatsink at all on it. And I'll see in a second how much I can crank it up to by connecting the speaker circuit there and hooking it up to an antenna so I can get some audio playing, and see if getting the audio amplifier generating some heat will push it a little higher. Oh, looky there. 110 Celsius, or about 230 Fahrenheit. And that's not been 20 minutes since the test started. About 10 minutes or so since I hooked up the antenna and the clip to enable the speaker, and the temperature keeps coming up. You can just start to feel a bit of heat coming through the case. But that's just been about 20 minutes operation, not even long enough for the heat to really start soaking through the components. And I'm going to terminate the test right there, because critical temperature for the devices in question is around 120 C and about 120 Celsius, and I don't want to push it past that point. I don't want to blow up stuff just for the grins and giggles of it. I know our radio's operated like that for a long time, but I don't want to tempt fate. But that's in a 70-some degree room with a controlled voltage source, keeping it within specified supply limits, and no heat, sun, anything shining on it. Think of it sitting in the top of a semi or in a car on a nice 100-degree day with the heat boiling down on it, and the thing cranked up because you got the windows down and the truck was responding on the CB and chatting all day as you're going down the highway, driving that little audio amp till it's about ready to puke. So the actual operating temperature that the thing's getting up to when you're heading down a highway on a hot day like that is at least probably 140, 150 degrees Celsius, 160, because I know it's getting to that point, because on all the radios that I've had come here, the solder that mounts the voltage regulator in place has melted, which means I know the components have been getting up close to 180 degrees Celsius under normal operating conditions, which is around 300 and some Fahrenheit. And as I said, they wonder why the equipment fails. Well, they probably know why the equipment fails. But like in this radio here, what I'm going to do is like I've done to the all the other radios, is I am going to get it disconnected here, and going to take and make up a little heatsink flange, which I will put in to connect, and nice and toasty, connect the heatsink for the audio amplifier and the heatsink flange for the TO220 voltage regulator, and connect it to the outside case to provide a heat dissipation path, which is something the manufacturer should have done in the first place. But as I said, I ain't being am not intending to be intentionally harsh on this manufacturer, because I've seen it in all manufacturers, not just this one. So neither here nor there. Got that out of my system, so to speak. The rant has been ranted. Take care. Whenever you're designing circuits that's using TO220 or other solid state mounting packages, even TO92 and whatever else, remember to, if you're going to be dissipating a reasonable amount of wattage, to please put an appropriate heat sink on it. Whenever it's running under normal lab conditions or normal workbench conditions, if the component is getting hot enough that you cannot physically put your finger on it without scalding yourself, then you probably made a mistake in your design. Either you've put too much load on it, more than you've expected, or you are dissipating too much heat for whatever mounting condition you've got the package in. So you need to start bulking up on the heatsink whenever that situation arises. Beyond that, take care. Have a nice day.